Hello everyone, in this video we are going to be setting up a Flask-based Docker application that interacts with Amazon Aurora Serverless using the Data API. And so this application is going to have two endpoints. One is going to be for create person and the other is going to be for get person. Then we're going to create a Amazon Aurora Serverless instance and we're going to have a persons table that is backed by it. And then in our application code, one of the things that we have to do is interact with AWS Secrets Manager, which is going to hold the credentials for our Amazon Aurora instance. So we're going to create a secret and store our credentials in there. That's what we're going to be doing in this video. So let's go and check out our code really quick. All right, guys, so here we are in Visual Studio Code. I already have a bunch of project files that exist that I've already prepared. And by the way, all of this code is going to be available on GitHub in the description section below, so you don't have to copy this stuff out of the video. So let's just walk through what's happening here really quick. So first of all, we have our app.py, which is going to be basically our entry point to our application. So we're just doing some basic imports up here. We're using Flask, of course. We're going to be using Boto 3, which is essentially the AWS SDK from the Python perspective to interact with the endpoints. We are doing some stuff here where we need to create a client, so a Boto 3 client, and we're going to be using RDS Data API. Passing in our config, we're also passing in our AWS secret access key. I would suggest you do this via a environment variable and don't hard code your credentials here, but I'm just doing this for the sake of simplicity and speed. Also, we have some configuration items set up here. So we have our Aurora database name, our Aurora cluster ARN, and then our Aurora secret ARN. Again, I suggest you pass these in via environment variables, and I kind of give you a quick little way that you can do that here. Obviously, we don't have these things yet because we haven't created our database yet, so none of this is filled out. So we're going to have to come back here a little bit later, and I'll walk you through how to do that. Then we have our get person API, which is a getter, and then we have our create person API, and this is going to be a post. Then we also have an abstraction down here that just takes in a SQL statement and we'll call our database using the data API. We're going to get to the details of how all this works a little bit later on. One other point that I wanted to make is that we are operating on port 8081, which does matter in the world of Docker if you need to set up any kind of port mappings. So that's our basic app.py file. Let's just take a quick look at the other files here. So we have first of all, a requirements.txt file, which contains all of our dependencies that we're going to be using in this project. I just essentially based this off an example I found somewhere else and modified it to fit my liking. But we have the things that we primarily need here. So Boto 3, Boto Core, AWS Web CLI if you want that as well. And then we have our Docker file. So this is a very simple Docker file. Let me just walk you through here. So we're going to copy our requirements over to a specific directory. We're going to set that directory to our working directory. We're going to install all of those modules from the requirements.txt file, copy everything over here to the app directory. We're going to expose port 8081, which is the port that we are operating on in our Docker container. Going to set our entry point. We're going to set the option -u. Now this I want to draw your attention to because if you do any print statements in your Docker container, they're not going to show up unless you have -u here. This is something I found out through failure. So take it from me, put the -u in there if you want logging or your print lines to show up in your Docker container so that you can debug it. So that's what we have in this application. So let's move over now to the AWS section of the console and get started creating our resources. Okay guys, so here we are in the AWS console. So I'm just going to go over to the RDS section so that we can get started creating our database. So typed in RDS, clicking on RDS over here, and hopefully this goes. Just seems to be a little bit slow today. All right, something's up. There we go. So I'm going to go over to the left-hand side here where it says databases. And then I'm going to be faced with this blank screen. So I don't have any databases on this account or else you would see them as line items here. So what we want to do is go to the top right and click on create database. So I'm going to click on this. And this is going to set up a wizard. So we're going to choose standard create here, not easy create, because it does set up things that we don't want for this demonstration. So scrolling down to engine options, we're going to be using Amazon Aurora, like we mentioned. I'm going to be doing this with the Postgres version, not MySQL. And so I'm just going to click on that tab there. Now, this section here for provisioned in serverless, make sure you click on serverless or else, you're going to have an instance that you have to worry about, which we definitely don't want in this exercise. I'm going to scroll down a little bit. So there are some details here that you may need to remember. So DB cluster identifier, you can leave this as default or give it something more meaningful. This is just going to be like it says, the cluster, the identifier for your cluster. So I'm just going to leave it as default for now. Now for master username, Postgres is fine. You probably want to set your password to something complex and meaningful, or just use auto-generate so that you don't have to worry about that and it generates something that is fairly complicated to guess. But for this case, since this is just a demo, I'm just going to set this to password. Very, very bad. Don't do that if this is any kind of production use case, but for me, that's fine. Okay, so let's scroll down a little bit more. So for capacity settings, this is essentially the auto scaling section of Amazon Aurora. The minimum is 2 units or 4 gigabytes of RAM, and the maximum is this absurd number. I don't want this to even get close to that, so I'm just going to set it to the lowest possible value, and that's good enough for me. Now for additional scaling configuration, there is a setting that I want to put here, and this can save you a little bit of money. So pause compute capacity after consecutive minutes of inactivity. So what this is going to do is essentially, like it says, pause your database so that after a period, it's just going to scale down. And then when traffic comes back in, it'll scale up. So I'm going to tick this box here. And I'm going to say I'm going to leave it as default actually. And I believe 5 minutes is the lowest. So after 5 minutes of no inactivity, it's going to scale down the compute. However, you are still going to be charged for storage. So keep that in mind. This only saves you on the compute costs. All right, so next we want to, actually we don't really want to do anything here for connectivity. We're just going to be using the default VPC. I'm not going to get into that in this video. Now you do want to click down here where it says additional configuration, and you want to enable the data API. Now the data API is a way to interact with RDS or Aurora Serverless rather, using a RESTful endpoint as opposed to using the database connection and forming a connection directly to that database. It's a great abstraction, and that's what we're going to be using because that's the suggested way using Amazon Aurora Serverless. Scrolling down a little bit more, so database authentication, we're going to be using password, that's fine. I don't think there's anything here in additional configurations. Oh, there is, my mistake. So initial database name. So you can name this whatever you want. I'm going to call this My Suite Database. So just jot down whatever you name yours because you're going to have to, we're going to have to change this in the code, and then in a later section, we're going to have to add some of these credentials to our secret. So just write that down or copy it to your clipboard. Scrolling down a little bit more, there is one other thing. So enable deletion protection. I want to disable this. If this is a production use case, you want to keep this enabled. This is just going to be easier for us to clean up our resources when we're done here. So untick that, and then we're going to go ahead and click on create database. So this is going to go to our next screen pretty quickly. However, it does take a few minutes. You see here where it says creating. So you may want to go grab a coffee or something and come back. When this says available, that's when we're going to proceed to our next step. All right, guys, so our database just completed creating. You can see here that it says status is available. So if we just click on this really quick to take a look at what it did, we can see here a bunch of options that are relevant to this instance, things like its endpoint. If you go to configuration, you can take a look at things like its ARN, other details as well. You can see here that our database name is My Suite Database, and these are the details of the capacity units that we allocated. Okay, so now the next step that we want to do is to go create a secret key that's going to store the credentials so that we can interact with this database, because we don't want to be putting in the username and the password directly. That's kind of an anti-pattern. So the suggested way is to interact with your credentials through AWS secrets. So let's go over to the secret section and do that. So I'm just going to duplicate this tab actually, because we're going to have to come back here a little bit later. And I'm going to go to the top and just type in secrets. Hopefully this doesn't blow up because it's loading other things. I'm going to click on Secrets Manager here. And Secrets Manager, it makes it very, very easy for you to store these credentials. And I'm going to show you how to do it here. So I'm going to go to Store New Secrets. And these are some of the other ones that I had previously, just messing around with this. And it just walks you through this wizard here. So let me tell you what it's asking you for. So credentials, it's asking you, first of all, for the secret type. So there's a bunch of different options here. They make it very easy. So if you select RDS, it's going to know that you're operating on a certain port and yada, yada, yada. So it pre-fills a bunch of the options for you. And then it's asking us for the username and the password. This is what we originally created a few minutes ago when we were creating our database instance. So I believe I named mine Postgres. and my password was just the word password. Just show you that's what I'm writing here. And for here, we can leave pretty much everything else default. The one thing that we want to do here, though, at the bottom is tick our database, the one that we just created. So this was mine, database 1, because it's going to pre-fill in some other options that the data API is going to use anyways. So this just makes it very convenient for us. So let's go ahead and click on next now. And it's just going to ask us at the top for description. So let's call this Aurora Serverless Demo Credentials. I believe I also have one similarly named, so remember that name for later on. Going to scroll down here, click on next. We don't need to do anything else. And then what do we have here? So key rotation, we're not going to do that because password's not going to change. So that's not recommended here. Click on next and should give us a summary. Yeah, so RDS database default, blah, 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 blah. Scroll down. Gives you some sample code on how to interact with it. We don't need this because we're going to interact with the data API, which does all of this behind the scenes. So you can just ignore that. Go ahead and click on store now. All right, so here in the next screen, it gives us back what we just created. So let's just click on this guy. And we can see here now that we have a secret ARN. I want you to copy this to your clipboard and maybe even put it in your notepad because we're going to need this, well, when we try to interact with the database through the data API. And when we modify our code, we're going to have to add the secret ARN in there so that we can access this secret. So just to show you what this thing actually did, so under secret value, if you go to retrieve secret value, you can see like this is all the stuff that is being stored inside of this secret. So you can kind of think of it as like a lockbox or a vault or something where only people that have permissions to read off of this secret can see what's inside of it. So it's a very handy way to isolate your credentials so that no one can access them. Putting credentials directly in code is always a bad idea, especially if you accidentally push that code to somewhere public like GitHub. So this way you don't have to worry about exposing this stuff. It's just kind of held in here. And as long as you don't give access away to your secrets, through IAM, then you should be good. So we can see here, username is Postgres. That's what we said. Password is password. And these are some extra things that it added automatically for us. When we selected the RDS type, it was smart enough to know that when you try to interact with this secret, you're probably going to need the other details of RDS. So it added all of this stuff in, which is very convenient for us. So that's all we need from this page. Just make sure that you copy the secret ARN here to your clipboard because we're going to need it pretty much right now. So let's close this tab here. We are back at the database section. Now, first of all, what I want to do here is just kind of interact with our database through the online editor here. So a neat thing about using the data API is that you can use this thing here, which is called the query editor, to kind of perform queries, do inserts, creates, maintenance, whatever you want to do really directly in your browser. So let's just show you what that looks like. So I clicked on query editor here. It's asking us for our cluster. So that's the only one I have here. And choose a username. So you have two options here. And this is kind of related to what we just discussed. You can do add new database credentials, and then you have to add your username and password. Again, like there's nothing wrong with this for this case, just doing it through the browser. However, what we're going to be doing later is through the secret. So let's just use this opportunity to test whether or not our secret is working correctly. So we're going to say correct with the secrets manager ARN. So I'm going to click that. And then it's just asking you for the ARN, which we just copied to our clipboard, or which you should have copied to your clipboard. And then it's asking us for the database name. So let's just say mine was my suite database. And just click off screen there, and this becomes highlightable. And we're going to say connect to database. So hopefully this worked, or else we're going to have an error. And come on, big money, big money, big money. Okay, so that took a really long time to connect. Usually it only takes a second or so, but this is what we got. We got this kind of editor page that looks very close to what you would see kind of in, SQL Server or any kind of GUI for interacting with the database. So this default query here just gives us some basic schema information. So if you click on run, you can see down below. If my scrolly wheel, what is happening? There we go. You can see some details about this, but we don't care about this. What we want to actually do is create our table here. So I'm going to use this opportunity to create our persons table. And I actually have some code already written here, so you don't have to watch me type for a million years. So let me just paste this in. So we are creating a persons table. We're setting the serial for person ID, and that's the primary key. Then we're just storing some very basic properties. So first name, last name, they're a varchar and they can't be null. So let's just run that now. We should get a success and success. So everything was created successfully. Now let's do a quick little insert, and I have that copied as well. So let me remove this and just insert a row. So person ID, first name, last name. You don't have to specify person ID here since we set it as serial, but I'm just doing that for whatever reason. Then our first name is going to be Daniel and last name is going to be G. So let's just click on run now. This should succeed as well. And that was a success. So let's just do a select star now from the persons table, star from persons, to make sure that everything worked and our record is now in there. All right, so now we have our person ID, 1, 2, 3, first name Daniel, last name G. Everything is pretty good here. What we now need to do is go and edit our code so that we can actually interact with this database programmatically as opposed to through the browser here. So just before I do that, I lost the ARN for the secret manager, which I'm going to need. So I'm just going to go back to secrets manager really quick and just grab that. So Aurora Serverless, grabbing this. Okay. So now let's go back to our code section, which is in this tab and back in app.py. So we can start filling out some of the details here. So I have some variables assigned down here. The first one is secret ARN. So let's just put that in. Oops. That was what we just copied. So that's pasted in there now. Our database name is, if you recall, my suite database. And we need the Aurora cluster ARN, and I didn't copy that. So let me go and grab that really quick. So back to Aurora. And this should be in the configuration section of Aurora. But let me just show you how to get there just in case anyone gets lost. So back into RDS, into databases now on the left. Click on the database you just created. Go to configuration. And here you go. This is the ARN, Amazon resource name. And we're going to copy this and just change our code to add that in there. Again, as I mentioned previously, you probably want to do this via environment variables, but we're not going to worry about that in this demonstration. Okay, so the other thing that I want to bring to your attention is that in this configuration section here, so I'm specifying the region that I'm operating in. Typically I use US East 1, but if you're creating your database somewhere different, then you want to change that. And to check what region you're in, it's just in the console in the top right here where it says North Virginia for me. That's US East 1, and whichever one you're in, if you're in Asia Pacific, you would put AP Northeast 2 there instead. But what I wanted to say was that when we're using this Boto3 client, it's asking us for a config object, which contains our region name that we're operating in. Now, it also contains the AWS access key ID and the AWS secret access key ID. Now, this is used basically for IAM credentials. So you can't just query a database unless you have the correct permissions to do so. So we need to create a user that's going to have two things. It needs to have access to RDS Aurora and specifically the data API portion of RDS Aurora. Then it's also going to need access to secrets managers so they can retrieve the secret, the one right here, the secret, because that's what stores the credentials. And behind the scenes, that's what the data API needs in order to actually query or interact with your database in any way. So what we need to do is go back to the console and we need to go to the IAM section. I'm going to duplicate tabs so I don't have to keep on opening and closing here, and creating a user with some particular policies associated with them. So going to IAM, clicking on that, and we're going to go to the user section. Okay. And I created one earlier, but that has all the permissions for us, but I want to just show you from scratch. So let me just do this again. So let's call this one RDS demo user. And we are going to be using programmatic access for this. And then next we're going to click on permissions. So it's asking us now, like, what do we want to give this user permission to do? So what we want to do here is attach existing policies directly. Now, lucky for us, the policies that we need are provided by AWS. So all you have to do here is type in Amazon RDS and it should be full access. Now this is a pretty comprehensive policy. If you actually expand this, you can see what's inside of it. So it gives you a whole bunch of stuff. It actually gives you access to Secrets Manager as well. And so you want this, but you may want to create a policy later that has more restrictive permissions, that doesn't have like everything here if you're not going to use it. But for all intensive purposes for this example, this is totally fine. Now, we did see that it gave us the secrets permissions, but I just kind of want to add that explicitly as well, just in case we're missing something. So I just typed in secrets here, and this logo, by the way, means that this is a policy that AWS creates and manages. So it's not something that is not trustworthy. So you can go ahead and click on this one as well. And we are going to add both of these. So let me just remove that. And we're going to click on next now. Next, and we should have a summary here. So yeah, it's showing us under permission summary that we have two policies that we're adding: Amazon RDS data full access and Secrets Manager read and write. Go ahead and click on create user in the bottom right now. And now we have the access key ID and the secret access key that we need for our code. So let's copy this, go over to our code. For access key ID, let's paste this in really quick. That's the key. And then here's the secret key. By the way, you shouldn't show this to anyone. I'm just showing you because this is a demo. However, I'm going to delete all this stuff later, but you never really want to show this to anyone. And more specifically, you don't want to do what I'm doing right now, which is putting this stuff directly in your code. You want to do it through an environment variable. But that's a different exercise. So let's paste in our secret key. And now everything should be good to go from the permissions and the setup side. So now what I want to do is just kind of walk you through our getPerson API, because it does some pretty interesting stuff. So I'm just going to expand this out. So in this API, this is a getter API. And essentially we're going to pass in an ID to this API. So if you remember, when I was inserting my first record, I used the ID 123. And then let's just walk through what's happening here. So we're extracting the person ID from the request, and then we're just using this statement here. You probably want to do something like escape, bad characters, or if someone tries to do like SQL injection. This is a very glaring vulnerability right now. You need to make sure that you're using either some kind of library to escape any potentially problematic strings that people pass in, or I'm not sure what the other options are, but kind of keep that in the back of your mind. Just notice a small error here. We're just doing a select star from persons. I don't think we want to do that. We want to say where person ID is equal to, and then I need to do like some plus magic here, open quotes plus, and let's just cast this to a string, and we're going to say person ID, because I can't remember if I'm going to pass in int or a string here, and then plus, and we just need to put the close quote there. So select star from persons where person ID is equal to whatever we're passing in. And then next we are, I'm going to go into the call DB statement in a second, but just run with me here. We're creating a response object that we are going to basically store. Then we are extracting the records array out of our response. Now the response is what we get back from the data API. And then we're doing this kind of magic here where we're going for record and records. We're getting the person ID, first name and last name. And we're using this wonky notation here. This is just the way the data API works. For every column, order matters. So the first column will be person ID, which is why I'm doing record 0. And since it's a serial, it's going to be a long value. The second column, or index 1, is first name, and that's a string. The third column, or index 2, is last name, and that's also a string. So I'm basically creating an object here that maps directly to the results that I should get back after performing the query. Then I'm just printing out the person object so that I can see it in my Docker container when we actually run this thing. And then finally, you can't return a dictionary back, so you need to JSONify it, which is what I'm doing. So let's go and take a look now at the call DB with statement function, which is really where the heavy lifting is happening. Okay. So what are we doing here? So we're saying response is equal to, and this is where we're using the RDS data client from Bodo 3, and we're calling the execute statement API. Now we are passing it a key, and the value is our name. whatever we called it. Mine was my suite database. We're giving it the resource ARN, which is what we stored in that variable. We're giving it the, secret ARN, and that's what we stored in that variable. Oh, it auto-completes for us. How lovely. And then we're giving it the SQL that we want to inject, and that's in the statement, which is what I just passed in. And this is optional. I'm not sure if everyone wants this, but the response doesn't show you the column names by default. Like I said, it only gives it back to you in ordered format. So if you want the column names, you can put this line in there here. It's not a very intuitive response. Even when it gives you the column names, you kind of need to parse it out in a custom way, which is not fun, but it's technically possible. I'm not going to do that in this video. I'm just going to leave this in here so you can see what it does. Okay, so print, I'm just calling this for debugging purposes. We're going to make this call to the data API. Then we're printing out directly what we're going to get back. Then we're returning that back in the response variable. And then that's going back here. And then we're running through the code. So that's essentially what this get person API does. So let's go and take a look at this in action. So what I need to do is I need to open my terminal here so I can build this first of all. Yeah, there we go. Terminal, there we go. And I think, I'm not sure why this is not looking, there we go. So I have a command that I usually use. So docker build -t Flask App, and make sure that you're in the right directory. So I need to go into app. Let's just clear this really quick. So docker build -t, and I'm just calling mine Flask App, and we're using current path. So this should build correctly. That looks good. And then we want to do to run. And so docker run -d, and we're using some port mapping. So 8081 on my Docker container is 8081 on my machine. And then we want our target to be Flask App. So this should spin up the container, and we see the hash was outputted. So if we go now to Docker, which I do have open, we can see now we have a running container. So if I just click on this guy, this is the logs essentially. So we're gonna go and invoke our API now and see what it returns. So let's go to Postman. Now, if you don't use Postman or you don't know what this tool is, it's just basically a thing that lets you call REST endpoints very easily. So that's what I'm using it for. You can go and download it. Just Google for Postman, and you can get a copy of this thing and play around with it. So we have our container running now, and it's on localhost since this is all local. And we're going to do /get person. And you can see here is where I was screwing around with this a little bit earlier. And what we want to do is add our params in here. And we said we take in person ID. And the original row that I put in was 1, 2, 3. So let's put in 1, 2, 3, click on send here. And we got an internal server error, which isn't good. And let's go and check out what we did wrong. So unrecognized client exception, the security token included in the request is invalid. So what does this mean? All right, guys, so I'm not sure exactly why that failed the first time. I literally didn't change anything in my code. I took a second look and I just ran it again after around a minute or so without changing a line, and it all worked correctly. So not sure what happened there. Maybe there's some kind of eventual consistency problem with AWS, but everything is looking good. So just bringing us into our Docker container now, this is where we kind of logged out some items. So I just wanted to show you because this will help you make sense of the code I wrote to extract the details out in this wonky way. So we see here making call select star from persons where person ID is equal to 1, 2, 3. And then we get this like wacky response back. So this is hard to read. So let's just go to my favorite website, which is JSON. I always just type that. Which lets you kind of paste in this poorly structured JSON and get some nice stuff back. And of course, I have something else here. So let me take that out and click on process. And there you go. So this is what we get back from the database call from the data API. So if we take a look at this really closely, you see this column or this key here, column metadata. So the fact that I had this here, which was include result metadata, that's why that column is, or those column details are showing up here. So if you didn't have that, this wouldn't show. But as you can see here, this is like a terrible format. It's not very meaningful. I mean, sure, you do have the label and everything in there, but not very easy to read. And for every column, you have this, which from a data payload perspective is not good because more data over the wire means more congestion and slower application performance. So I would suggest you don't do this unless you absolutely need it, because it's just a waste. However, if you go all the way down to the bottom and under the records section, you can see here, this is our person ID. Remember, I originally created that. This is our first name. You can see here, like, this doesn't mean anything, string value. And this is the last name here, G, also string value. So this is the reason I had this weird parsing going on here. So I'm extracting the records out. I'm going over each one. I'm assigning the person ID to whatever's in first position as long value, second position string value, which is first name, third position string value, which is last name. So that's why I did what I did. So hopefully this makes a little bit more sense here. Well, we can see that as a result of this Postman call, I tried this again, by the way, and it is indeed working correctly now. And if I just click on send a couple more times, you can see this isn't going to change. So we are good to go from the get person API. Now we want to do the similar thing for the create person. I already kind of coded that up for you. So let's check that out. So create person, and since this is a post request, the semantics for getting the input are slightly different. So in order to get the person ID, we need to use this request data thing and then extract the person ID out of it. Since this API takes in a couple other properties, such as first name or last name, that's what we want to insert into our database. I'm just extracting those values out here. And then I am I'm making a call to this runner function or helper function to insert into the person's table the person ID, first name, last name, values, and then I'm just providing everything from up here one for one. Again, you probably want to do some NoSQL injection escaping so that you don't kind of end up blowing out your table as a result of someone submitting some kind of malformed first name. But anyways, that's a topic for a different video. Now, with this API here, this is already on our container, so we don't need to rebuild and rerun or anything. So if I just go to Postman now, and this, I'm going to make a new tab for this actually, so we can leave this all intact. So copy that out, click on the plus and localhost there, and this one's called create person. Now, also remember, this is a post, so we can't put things through the query string. We need to do so through the body. So let's go to body. We're going to set this to raw, and then we're going to set this to JSON. And let's just have the field names here on the side behind. So it's person ID, first name, and last name. That's what we want to add here. So we want to create a, let's say, person ID. And you got to be careful here with your types. If you pass in an integer here, if you don't have the cast like I had over here, this isn't going to work because it expects a string when you pass it into the data API. And then we want first name. Let's put the name of my wife here. And last name. And Tiffany is also Tiffany G. Okay, so this looks good. Click on send now. Hopefully this worked. And again, another internal error. So let's see what this one was. Of course. So yeah, error, duplicate key values violates unique constraint. So we cannot use 1, 2, 3 here. Of course, I should have thought of that in advance. You make it 1, 2, 3, 4. And again, so I think I know why this is erroring out. It's because I'm not returning a valid response here. Well, I'm not returning anything, and I believe the post request expects that by default. So I'll prove to you, like, you can fix this very easily by just adding like a return empty string. But let me just add a couple people in here, and then we're going to go over to our database. You can see this is going to supposedly error out every time. However, we'll see in a second here that it's actually successfully writing. So I just added a bunch of Tiffany's in here with different IDs. So let's go back to the RDS console now and just use the query editor really quick to confirm that everything is working correctly. So here I am in the query editor again. We're just going to do a quick select star from persons, and we should have a whole bunch of rows returned back to us. And you can see here we have a whole bunch of Tiffany's in response to me spamming that button every time. I'll just do it again really quick to prove it to you. So let's make this. We'll add another one. We'll add another one and run this again. This should grow by like 3 or so. And so there you go. So you see there's all these different entries in our database now. So if you want to deploy this application out to AWS using ECS, I suggest you watch the video on the right. And if you want to deploy this application to Fargate using a load balancer, watch the video on the left. Thanks so much, and I'll see you next time.